Hello everyone, welcome to HDI. My name is Yaya. I'm a senior spectrum engineer. So today I'm going to walk you through a step-by-step training, a brief one, and very focused on parallel coverage computations. Recently, guys, very recently, on the 6th of September 2021, this year, that's very recent, we removed the cap. We removed the limitation of how many concurrent sessions of HTZ you can run in parallel for the purpose of remote simulations or parallel computations. So it's in a very specific context. Say you have a massive network like 100 or 1,000 base stations or million base stations. Usually or classically, you would run sequential coverage predictions. So site 1 followed by site 2, site 3, and so on. We have a feature in the tool that can actually run coverage predictions for multiple sites concurrently. So you can be doing batches, 10, 20, 30. You can run them in parallel. Previously, that was tied to the number of licenses you have. So a typical standalone license can only support two sessions, two parallel computations. And we removed that cap recently in this context. If you are running coverage predictions using remote simulation functionality, which I'm going to talk about it soon. So your limit becomes your hardware, your computer, how much RAM you have, how much CPUs, or how much threads, cores you have, and so on. So let's get started and then walk you through the process of converting your standard project into a parallel computation project. So first I'm going to talk a little bit about the concept here. So the concept is we need to use a database. When we talk about parallel computations and multi-sessions of the software, so imagine that you've got multiple people working concurrently, you need to have some sort of orchestrating database. So we call it the internal station database. You must use this database as your repository or your database for your network parameters and your coverage predictions and so on. Most of the people are using EWFX. Some people use SQL, for example. Okay, EWFX is our native file format that we use as a database, but you must push this information into an internal station database to make use of this feature. So the idea is to use multiple sessions. So I'm not saying you have to run HTZ 20 times. No, you run it once, but the software will automatically generate multiple sessions opened concurrently, automatically, in order to break down the problem into smaller problems and then speed up the process. And that allow you to jump your CPU from 10-15% possibly to 80-90% utilization or higher, depending how many sessions you want to run. So the concept is, like I said, is to do multiple coverage predictions. So we are only talking about coverage predictions. I'm not talking about coverage analysis or frequency assignment or interference analysis. So specifically talking about coverage calculations. And usually this is the tedious job. That's the part of the network which really take time. I mean, sometimes you might need to spend 5 days just on coverage predictions if it's a big network. And this is a major obstacle or major challenge when we talk about 3D maps, 2-meter resolution, 1-meter resolution maps, and so on. These kind of maps, running coverage prediction for one site can take you 10 minutes, okay, depending on the radius of coverage computations. So this is a solution specifically or become very, very important when we talk about 5G or IoTs. Okay, so in 5G context, because I expect you're going to use high resolution maps for the cities, urbans, and so on, and you have so many sites, and you need to do coverage predictions perhaps up to 2 kilometers or 3 kilometers sometimes. So the tool is going to consume roughly about 4 gig per session. Okay, so you have to think about your computer specs. So if you have, if you want to run 10 sessions concurrently, you might need up to 40 gigs of RAM. Okay, so you also need high number of CPU cores. Okay, and if you have 5 cores, then you could have five concurrent sessions. At the end of the day, it's number of threads, how many threads you have. And in a cloud context, they will talk about virtual CPUs. So virtual CPU is a thread. Okay, so that's the idea here. You can see the image in the bottom right corner. So you've got multiple sections of HTZ, all connected to the same database, all running together in parallel to achieve a desired outcome. So let's dig into this and then show you how to get this done. So I made a small example because obviously I don't want to spend half a day. Half a day is very efficient, but I'm not going to spend half a day doing simulation for you. So I'm going to show you the process to set up this. So what do I have here? I have here a high-res digital terrain model. This is a high resolution, and there's a clutter coming with it. This is a clutter. It's not colored properly, but that's fine. And we've got a building layer here, okay, and you've got some imagery. So this is a high resolution map. And you can see here the sites. These are example 5G sites that we have. So you see running 5G TDD, 115 roughly watt per beam, and you've got here your gain, your frequency, antenna height, and beam forming antenna, and so on. So this is my network, and this network right now has about 79 sectors. Okay, so roughly 80 sectors we're looking at here in that dummy network. And obviously we are using here propagation model, which is fully deterministic. So you've got here the Dago diffraction, and we've got the coarse integration to speed up a little bit computations. So this is a deterministic propagation model, not some empirical one. Empirical ones are usually fast by default, but they don't really utilize the 3D maps that we have available. So, and also just to quickly walk you through the settings, if we're looking at 1K, 1 kilometer radius per sector, we're going to run coverage computations. So the traditional way, which is you go coverage, network calculation, TXRX, right? And then you specify receiver height and radius, and you hit OK. So that's the sequential classical approach. So this can be a problem if you have a million, or 1,000, if you have 20,000, 50,000 sites, and if you're doing this for 3 kilometers, it's a big problem. So I'm gonna let it run just slightly, just to give you a feeling. Okay, so right now we spend 22 seconds, 23 seconds, 24, and we are halfway through. So this is the sequential method, or the non-parallel computation method. So let's make it run. And let's take a note. So right now it's 49 seconds, 50 seconds, 53, 55. And I didn't even enable the multipath, the 3D ray tracing, which makes things even harder in terms of computations. So that's the coverage, and it took us roughly 1 minute, right? Roughly 1 minute. So this is the traditional approach. Roughly 60 seconds. Okay, so let's now look at the other approach and see how much time it takes. So the other approach requires one-time database setup. So to do this, you go to list, and then you go to database station. That's how you can generate database station. A lot of customers don't use this approach. Some of them do, okay? So depending on your requirements. So we go to database station here, and we make a new link. So in the new link, I'm going to generate here, I'm going to create a folder, call it station database. And inside that folder, you navigate inside, and then you give it a title. So let's call it 5G parallel, for example. So the process is simple, guys. I went to database station under the list, and then I made a new link. And that new link, I created a folder, and then in that folder, I'm going to generate a file with .dat extension. That's ATDI native parallel, native database format, which could be accessed in a parallel fashion. So hit OK, here we go. Double click on it, it's empty. That makes sense. So we generated that database outside the software. Now it's time to push or export this network and put it in a database. The process is simple. You go to database, station database, and then export activated elements. So this is how you push from the map to the database. And these two, the map and the database, are not linked. They are isolated. They are independent. So anytime you want to push and pull information, you need to do it manually. Okay. So it's external database, and this is on the map is related to EWFX. So if you want to push something, you need to do it like this. If you want to export from the map to the database, you go export activated elements. So you select the database you want to export to, and here we go, done. So now I managed to export what's on the map. So it's, guys, really simple to create a database and push the information you already have. It's very simple. So you go to list now, station list. Sorry, you go to list and then database station, and you see here we've got the 5G parallel. Double click on it and select all. Here we go. So this is a replica of what you see on the map, but sitting this time in an internal database. This is what's going to help me run the simulation in a parallel fashion. Now remember, the version of the software you need to be using, it should be released after the 6th of November. Sorry, 6th of August. So back to the software here. So these are the sectors. You can right click and go to parameters if you want to see the parameters of this, and you can check if there's a coverage and so on. Okay, so select all. This is my replica of my network. So close this. Now I'm gonna delete this. You don't have to delete them really, but I'm gonna delete them just to make it less confusing. So now I lost my map here. Okay, I've got no network. I've got no network on my map. So I go back to the list here, database station. Double click on this 5G. You see here, you still have them here, and you can in fact push them to the map if you want. You can put them on the map. So it's another way to save or back up your network. So now I wanted to show you how you can run the coverage computations in parallel. So from the database, you don't have to use the map. Okay, no need for the map. So we go here to remote simulation. You see this button here, remote simulation. First, select all, make sure all the network is selected. Second, go to remote simulation. And here you can specify how many threads you're gonna use. So I'm going to use only one installation of the software. Now here the idea is that you could actually run HTC on multiple computers if you need to. Okay, so in this exercise, I'm gonna focus on doing this on one computer. And we're going to use up to 10 threads. Up to 10 threads. So which means it's going to run 10 parallel computations. Okay, maybe 10 is too much. Let's go 5. Let's go 5. So I'm going to use 5 for now. It's actually tempting to use 10. Let's go with 10. See if that works. Hopefully I have enough RAM on my computer. And DTM sampling, keep it to 1 because you want to keep the high resolution available to you. Now the software will give you a recommendation depending on the computer specs. So the computer recommended sampling factor. This is actually this is number of threads recommended based on the current computer specs. So coverage settings, you can revise your settings. We're gonna use the same PRM. So remember, we're gonna use the 10 sessions here. Hopefully we'll run okay, and that's pretty much it. So I just hit OK, and that should run the simulation. So you see now the software started generating multiple sessions automatically. So it's gonna make 10 sessions. So let's see where we are now. Here we go. Here you go. So now I'm going to start timing. I forgot to start timing sooner. So I'll start timing now. So now it's almost 15 seconds. That's it, done, finished. So it took less than 30 seconds. Less than 30 seconds. Okay, so the gain here is significant. The gain is significant. So the software now finished, and what happened is now, if you want to see the outcome, you go back to the list, and you go back to the database station. Double click. Now these sites have a fresh coverage attached to them now, based on these recent simulations. So here I've got roughly 20 seconds. So this is the remote simulation approach. So roughly 20 seconds. Now you can't say yet that your gain is double or triple. You can't say that yet. So you need to set up a proper example, like more sites. You need to set up an example with maybe 100 sites and 5-kilometer radius, and then you see the significant gain. The gain is really linear. It's a very high gain you expect usually. So back to the software here now. Select all and then put them on the map. Okay, put them on the map plus the coverage. So bring the coverage with you from the database. So close, and now Control C. So you see this is the coverage. So that coverage was computed with a fraction the time, higher speed, and using the native resolution, which is the 2-meter resolution. So the outcome of this exercise is that you can really easily set up a remote simulation folder for parallel computations, and you can realize the exponential gain of the linear gain from using this feature. Now again, I'm going to remind you that this feature has always existed in the software, but recently in August we removed the cap. Now there's unlimited cals. So you get every customer who is under maintenance and eligible for a software release after that date will automatically be able to enjoy that feature if you know how to set up this database and run the coverage computations. That's it for this session, and if you have any questions, please submit towards the end of this session.